Good day, grade and learners. I am Teacher Anna and welcome to another Mathenic episode. Today, we will learn about how to graph a polynomial functions. Are you ready? But before we start, kindly prepare your self-learning module, your pen, and paper to write your solutions and answers as we progress with our discussion. Also, look for a place in your home where you feel comfortable and safe. And most importantly, prepare yourself to watch and listen carefully. At the end of this lesson, you are expected to illustrate polynomial functions, understand, describe, and interpret the graphs of polynomial functions. Let's begin. What is a polynomial function? A polynomial function is a function of the form p of x, which is equal to a sub n multiplied to x raised to n plus a sub n minus 1 multiplied to x raised to n minus 1 until we reach plus a sub 1 multiplied to x plus a sub 0, wherein the value of a sub n is not equal to 0. In here, n is a non-negative integer and it is the degree of the polynomial, while a sub 0, a sub 1, and a sub n are real numbers called coefficients. And a sub n multiplied to x raised to n is the leading term, and a sub n is the leading coefficient, and a sub 0 is the constant term. Let us have some example to understand it better. Example number 1. F of x is equal to x raised to 3 plus 3x raised to 2 minus 4x minus 12. Identifying the degree of the given polynomial function, it means identifying the highest exponent. And the highest exponent is 3. And it only means that the degree of the given polynomial function is 3. Next, we need to identify the leading term. The leading term is the term where the highest exponent belongs, and that is x raised to 3. And the leading coefficient is the coefficient included in the leading term. So we have x raised to 3 as the leading term, and we don't see any coefficient, but it means that we have an imaginary 1. So we write 1. And lastly, identifying the constant term. It is the term wherein it doesn't have any variable. And in the given polynomial function, that is negative 12. Next example, we have p of x, which is equal to 2x raised to 4 plus 7x raised to 3 minus 4x raised to 2 minus 27x minus 18. The degree of the given polynomial function is 4, and that is the highest exponent, and the leading term is 2x raised to 4, and the leading coefficient is 2. And lastly, the constant term is negative 18. So, how do we graph a polynomial functions? To sketch the graph of any polynomial function, you can start by finding the zeros of the function and end behavior of the function. In order for us to do that, we need to follow the following steps. Step number 1. Write the function in factored form. For example, graph the polynomial function x raised to 3 minus 2x raised to 2 minus 3x. So we have p of x, which is equal to x raised to 3 minus 2x raised to 2 minus 3x. And the common factor that I have is x. So we have x multiplied to x raised to 2 minus 2x minus 3. And the factor factored form of x raised to 2 minus 2x minus 3 is x minus 3 multiplied to x plus 1. And the factored form of the given polynomial function is phi of x, which is equal to x multiplied to x minus 3 multiplied to x plus 1. Step number 2. Find the end behavior of the graph of a given polynomial function with the use of the leading coefficient test. So there are 4 cases that go with this test. Given a polynomial function in standard form, f of x, which is equal to a sub n multiplied to x raised to n plus a sub n minus 1 multiplied to x raised to n minus 1 until we reach plus a sub 1 multiplied to x plus a sub 0. So for case number 1, if n is odd and the leading coefficient a sub n is positive, the graph falls to the left and rises to the right. For case number 2, if the value of n is odd and the leading coefficient a sub n is negative, the graph rises to the left and falls to the right. And for case number 3, if the value of n is even and the leading coefficient a sub n is positive, the graph rises to the left and to the right. And for case number 4, if the value of n is even and the leading coefficient a sub n is negative, the graph falls to the left and to the right. Let us identify the end behavior of the graph of the given polynomial function x raised to 3 minus 2x raised to 2 minus 3x. The degree of the given polynomial function is 3, and 3 is an odd number. And the sign of the leading coefficient is positive. Therefore, it falls under case number 1, wherein if the value of n is odd and the leading coefficient a sub n is positive, the graph falls to the left and rises to the right. Again, the graph falls to the left and rises to the right. Step number 3. Find the zeros of a polynomial function and their multiplicity. If the multiplicity of 0 or c is even, the graph touches the x-axis at c, but it does not change from one side to the other side of c. And if the multiplicity of 0 or c is odd, it crosses the x-axis at c and changes from one side to the other side of c. And to identify the zeros of a polynomial function, we need to equate the factored form to 0. In our given example, the factored form of x raised to 3 minus 2x raised to 2 minus 3x is x multiplied to x minus 3 multiplied to x plus 1. So we equate them to 0. We have x, which is equal to 0, and x minus 3 equals 0, and transposing negative 3, the value of x is equal to 3, and x plus 1 is equal to 0. Transposing positive 1, we have x, which is equal to negative 1. And zeros of the function are x, which is equal to negative 1, 0, and 3. Since the zeros of the function only occur once, which means they only have multiplicity of 1, which is an odd number, it means that they crosses the x-axis at negative 1, 0, and 3, and they changes from one side to the other side of c. It means if it came from downwards, it will go upward, and if it came from upward, it will go downward. Step number 4. Make a table of values of x and y to identify some points of the graph. So we have x, which is equal to -3, -2, -1, 0, 1, 2, 3, and 4. The list may continue as you wish. And since we already know the zeros of the given polynomial function, which is -1, 0, and 3, we don't need to solve for them. Automatically, we write 0. And in order for us to identify the value of p of x, we need to substitute the given values of x to the given polynomial function x raised to 3 minus 2x raised to 2 minus 3x. Let's begin with -3. If we substitute -3 to the given polynomial function, we will come up with -36. And for -2, we have -10. And for 1, we have -4. And for 2, we have -6. And lastly, for 4, we have +20. And for our last step, plot the points and draw a smooth, continuous set curve to connect the points. But before we do that, one important note that we need to remember is that the graph of a polynomial function is continuous, smooth, and has rounded turns. Further, the number of turning points in the graph of a polynomial function is strictly less than the degree of the polynomial. In our example, we have x raised to 3 minus 2x raised to 2 minus 3x. Identifying the number of turning points, we have the degree of the polynomial minus 1. The degree of the polynomial is 3. So we have 3 minus 1, which is equal to 2. So we have 2 turning points when we graph the polynomial function. And lastly, the graphs of the polynomial functions must satisfy the vertical line test. So the graph of the polynomial function x raised to 3 minus 2x raised to 2 minus 3x has 2 turning points, and it also crosses the x-axis at 0, 3, and -1. And the end behavior of the graph falls to the left and rises to the right. And now, grab your pen and paper and let us all graph the polynomial function of the quantity x minus 1 raised to 3 multiplied to the quantity x plus 2 raised to 2. For step number 1, within 30 seconds, write the function in factored form. Very good. The function is already in factored form, so we only write it as it is. So we have p of x, which is equal to x minus 1 raised to 3 multiplied to the quantity x plus 2 raised to 2. So for step number 2, within 30 seconds, find the end behavior of the graph. Okay, the degree of the given polynomial function is 5. You just add 3 and 2, so we have 3 plus 2, which is equal to 5, which is an odd number, and the sign of the leading coefficient is positive. Therefore, it falls under case number 1, wherein the value of n is odd, and the leading coefficient a sub n is a positive, and the graph falls to the left and rises to the right. So for step number 3, within 30 seconds, find the zeros of a polynomial function and their multiplicity. Very good. The zeros of the function are x equals to -2 and 1, with multiplicities 2 and 3 respectively. Note that the 0, 1 has odd multiplicity, so the graph crosses the x-axis at the x-intercept 1, but the 0, -2 has even multiplicity, so the graph touches the x-axis at the x-intercept -2. And for step number 4, since we are making a table of values to find several points, which will take time, I will provide the answers. So we have x, which is equal to -3, and the value of the polynomial function is -64. And if the value of x is -2, the value of the polynomial function is 0. And if the value of x is -1, the value of the polynomial function is -8. And if x is 0, p of x is equal to -4. And if the value of x is equal to 1, the value of p of x is 0. And the value of x is 2, the value of p of x is equal to 16. And for step number 5, plot the points and draw a smooth continuous curve to connect the points. But before that, we need to identify the number of turning points. So the degree of polynomial minus 1. The degree of the polynomial is 5, so 5 minus 1 is 4. So the number of turning points is 4. So the graph of the polynomial function of the quantity x minus 1 raised to 3 multiplied to x plus 2 raised to 2 has only 4 turning points. And again, the graph falls to the left and rises to the right. And it only touches the x-axis at the x-intercept -2, but it crosses the x-axis at the x-intercept 1. And that's it. I hope you learned something today. Again, this is Teacher Anna, and see you on another Mathenic episode.